Mm. Hello everyone, welcome to the next session of fluid mechanics and hydraulic machines, and in this class I will be starting fluid dynamics, which is the second part of unit 2. So the second part of unit 2 is fluid dynamics. In unit 1 we have studied about fluid statics, in which the fluid is at rest. In unit 2 we studied about fluid kinematics, in which fluid is in motion, but we were not considering the forces which were causing motion. In fluid dynamics, the fluid is in motion and we will be considering the forces which are responsible for motion. So fluid dynamics deals with the study of fluids in motion, considering the forces responsible for motion. So the different forces which we are going to consider are the pressure force, gravity force. Gravity force is also called as weight because weight is because of gravity. So pressure force, gravity force, viscous force, compressibility force. So all these forces are there in liquid. Next is turbulence force. So these are the different types of forces which liquid poses. So usually in fluid dynamics we will be taking only two forces into consideration in order to make the analysis simpler, that is pressure force and gravity force. Okay. So in the coming topics we will be studying in detail about the rest three forces, which is the viscous force, compressibility force and turbulence force. So initially we will be taking only two forces into consideration, that is pressure force and gravity force. So the next thing you have to understand, in order to understand fluid dynamics in a better way, you have to understand what is discharge, because I will be coming across this term discharge number of times while I derive the equations. So discharge is the amount or quantity of fluid flowing per unit time. Okay. So we denote discharge with letter Q. So Q is called as discharge. So the general formula is volume by time. So how much volume is flowing in some amount of time? For example, 1 liter per second if I say, that means 1 liter of volume is coming in 1 second. If I say 5 liters per second, means from that section 5 liters of volume is coming in 1 second. So volume by time. So what will be the SI unit? What is the SI unit of volume? Volume is meter cube and the SI unit of time is second. Okay. So volume can be written as area into length. Area into length by time. So in place of volume I have written area into length by time, and this length by time is called as velocity. Length per unit time is velocity. So discharge is also area into velocity. So we have got two formulas of discharge. We can say volume by time, which is V by T. This is capital V, or area into velocity, A into V. This is small v, which is velocity, and this capital V is volume. So we have got two formulas, either volume by time or area into velocity. So both are the formulas of discharge. So in order to understand discharge in a better way, I'll take one example. If you have a tank, let's say you have a tank which has a capacity. Okay, generally your household tank has got two types of pipes. One is the filling pipe or the input pipe from which the tank is filled, and one is the output, which is the supply type of pipe. So let's say that the capacity of this tank which you are using is 1000 liters. Okay, 1000 liters is the capacity of tank, and this is the input to the pipe and this is the outlet. So let's say this, from the input you have discharge of 10 liters per second. Okay, and the output is closed and I haven't opened the output yet. So how much time, and the tank is empty, how much time will it take to fill the tank? Okay, because 10 liters of water is coming in 1 second. The discharge from the input is 10 liters per second. That means 10 liter of this tank will be filled in 1 second. 10 liter of volume is coming from this pipe in 1 second. So that's the use of discharge here. This 10 liters per second will indicate the discharge. So we have got different discharge measuring devices which we'll be studying further. So the different discharge measuring devices are venturimeter, orifice meter, nozzle meter, bend meter. All those devices we'll be studying in detail. So this value we'll be getting from that discharge measuring device, which we are going to attach at one of the ends where we have to find the discharge. So 10 liters per second means 10 liter of volume is coming in 1 second. So how much time will it take to fill the tank? Because the capacity is 1000 liters, it will take 100 seconds, because 10 liters in 1 second. So for filling 1000 liters, it will take 10 into 100. That means 1000 liters of the tank will be filled in 100 seconds. Okay. So that's about discharge. Next topic is so you have to remember the formula of discharge. Next is discharge or continuity equation, through controlled volume. This is usually asked in short answers for 2 or 3 marks. Continuity equation through controlled volume. So let's say we have a pipe, some non-uniform pipe section, and you have got two sections, section 1 and section 2. So you can say from law of conservation of mass rate is constant. Mass rate is equals to constant. What do you mean by mass rate? Mass rate means mass by time is equals to constant. So mass can be written as density into volume. So in place of mass, I can write down density into volume by time is equals to constant. Okay. So density into volume by time is called as discharge. So density into volume by time is discharge, Q, is equals to constant. Okay. So density into discharge is equals to constant. If incompressible flow is there, if flow is incompressible, then density will become constant. Okay. So this density is a constant value. On the right side you have a constant value. If you send it to the right side, you will get constant by constant, some constant value we will get. For example, this constant value is 500 and this is 100. So 500 by 100 is 50. So you will get some constant value. So Q is equals to constant. This is called as continuity equation through controlled value, through controlled volume. So Q, what is the formula of Q? Q is area into velocity. So area into velocity is equals to constant. Q is equals to area into velocity is equals to constant. So area into velocity will be same at section 1 and section 2. So we can write that as Q is equals to A1 V1 is equals to A2 V2, so on. How many number of terms we have, that many number of. So this is called as continuity equation through controlled volume. So this is the first derivation, which is a short derivation usually asked in short answers. But this formula we will be using for solving problems. I will be giving that in all the list of the formulas. The next derivation is Bernoulli's equation from Euler's equation. So this is very, very important. I'm giving 3 stars. Bernoulli's equation, obtained Bernoulli's equation by integration of Euler's equation. From integration of Euler's equation. So first we are going to derive Euler's equation, then we are going to integrate that Euler's equation so that we can obtain Bernoulli's equation. So first we are going to derive Euler's equation. So in this equation, the forces due to pressure and gravity are taken into consideration. Consider a stream tube of length ds and cross section area dA. Okay, so we are going to consider one stream tube, a stream of water. Okay, and this water is having a cross section of area of dA, and the length of this length of water is ds. So what are the different forces acting on this is, one is the pressure force and the second is gravity force. So the pressure force acting on this side is pressure into area. So what is this area? dA. So pressure into area. On the other side, because the height is increasing, the pressure will also increase. So pressure will become P plus dP. Area is the same, so P plus dP into dA. So the next force which is acting is weight. So weight always acts at the center and the direction of weight is vertically downwards. So W is equals to mg. Okay, and because this is inclined to this body, so let's say the weight is having an angle of theta with this direction along the length of the tube. So now this weight will have two components. One will be in this direction, which is W cos theta, and one will be in this direction, which is W sin theta. Okay, so now I can apply Newton's second law, because in fluid dynamics the bodies are in motion. Okay, so we have to apply sigma F is equals to ma, which is your Newton's second law. So from Newton's second law, sigma F is equals to ma. Okay, so what is mass? Mass can be written as density into volume. So can you see this term W mass m into g here? So mass can be written as density into volume. So what is the density here? Density is rho. And what is the volume of this? Volume is area of cross section into length. So dA into ds will become your volume. So rho into dA into ds is volume. So mass is density into volume. So g as it is. So W is mg. Mass is density into volume, because volume is dA into ds. G is as it is. Next, one more thing. If you see this length is ds and this height is dz from the ground. So the angle between them is theta. So ds and dz. So angle between them is theta. Okay. So acceleration is there. Next is acceleration is rate of change of velocity. Okay. So if I multiply dou s into dou s for acceleration, dou v by dou s will become as it is. Dou v by dou s is as it is. What is remaining? ds by dt. So ds by dt is rate of change of displacement, which is called as velocity. So acceleration can be written as v into dou v by dou s. Okay. So in place of acceleration, here I can write down v into dou v by dou s, because we want in terms of displacement, that's why we are doing that. So in place of acceleration, I can write down v into dou v by dou s, and in place of weight I can write down this term wherever we have these terms. So sigma F is equals to ma. So forces in the direction of motion. So this is the direction of motion. So this is the direction of motion. The fluid is flowing in this direction. So this will be positive direction and opposite direction will be negative direction. So along the positive direction we have got one force which is PdA. In the opposite direction we have one force which is minus W cos theta. Because it is in opposite direction we are going to take it as minus. One more force we have in opposite direction, that is minus P plus dP into dA. Okay, M. What is M? Mass is density into volume. So we have density into volume here. So density into volume. Okay, acceleration is V into dou V by dou S. Okay, so PdA minus weight we got it as rho dA dsg. So rho dA dsg. What is cos theta from this? So cos theta is adjacent by hypotenuse. So dz by ds. So in place of cos theta I can write down dz by ds. I can open this bracket, so we'll get two terms, minus PdA minus into plus minus dP into dA. Okay, on the right side we have rho dA ds to V into dou V by dou S. Okay, so next this ds and this ds gets cancelled. Similarly here also plus PdA minus PdA gets cancelled. Okay, next what is remaining? Minus rho dA g into dz is remaining, minus dP dA is remaining. Next rho dA V into dou V is remaining, because here also we have ds is to gets cancelled. So what's remaining now? Minus rho into dA into g dz minus dP dA is equals to rho dA into dou V. Okay, next I can take these two terms on the other side, it will become positive. So rho dA g dz plus dP dA plus rho dA dou V is equals to 0. Dou V or dV, whatever it may be. So next we are going to take dA common from this. So what's remaining? Rho g dz plus dP plus rho dV is equals to 0. We can take here differentiation, no need of partial differentiation. Please make a change here. Okay, so dA I can send it to the right side. So what's remaining? Rho g dz plus dP plus rho dV is equals to 0. So if I take rho common from this, what will be remaining? G dz plus dP by rho plus dV is equals to 0. Okay, sorry, VdV is there. VdV. So what's remaining now? dP by rho. So rho if I am sending to the right side, so 0 by rho it will become 0. dP by rho plus VdV plus GdZ is equals to 0. So this equation is called as Euler's equation. The above equation is called Euler's equation. So on integrating Euler's equation, we are going to get Bernoulli's equation. Integrating Euler's equation, we get Bernoulli's equation. So integrating that equation, integral dp by rho plus integral v dv plus integral g dz is equals to integral 0. So integral dp by rho, so integration with respect to p, so we will get p by rho plus integral with respect to v, so we have v square by 2. Integration with respect to integral dz will become z, so gz is equals to integral 0, we have constant. Okay, so if I divide by g on both sides, we have p by rho g p by rho g plus v square by 2g plus z is equals to constant. This is called as Euler's equation, Bernoulli's equation. This is Bernoulli's equation. This term p by rho g is called as pressure head, v square by 2g is called as velocity head, z is called as datum head. P is called, this term is called as pressure head, this term is called as velocity head, this term is called as datum head. So Euler's equation is defined as the sum of pressure head, velocity head and datum head at any point is constant. So this all together is called as total head. Okay. So sometimes in the question he'll ask you to find out the total head, so that you have to find out p by rho g plus v square by 2g plus z is equals to constant. Okay. Okay, then that's it for today. Thank you everyone.